Welcome to the Decoding HVAC Podcast, powered by Fujitsu Airstage, bringing you smart solutions, industry trends, and pro tips to keep you in the know. Well, Matt, let's talk about inverter technology. What is it, how it works, and most importantly, why would I want an inverter HVAC system?
Yeah, so I'll make this very simple. So inverter, essentially what we're dealing with is a variable speed outdoor unit. Kind of getting back to some other episodes that we talked about on having a home central system. When that thermostat calls for it to come on, whether you're in heating mode or cooling mode, whatever that fan performance is, it's blowing air. So you look at back in the central air conditioning side, variable speed indoor units became much more popular, probably, we'll call it last 15 years. That's about 12 to 15 years. A lot of the unitary or the traditional split technology would use a variable speed on the indoor to get its efficiency. With inverter technology, I'm actually taking that variable speed component and taking it to the outdoor unit. So now, instead of having my unit say, hey, I need heating, cooling, and I'm at 100% full force, now I'm at a variable speed on my outdoor. Now I can actually slow that down to account for a demand that I have that I may not need it to be at 100%. And I'm much more efficient by doing it that way.
So we're not going from 0 to 100 and then back to 0 all the time. We're running at a less of a cycle, I guess, for lack of a better term.
I think you like the outdoors too, just like I do. And I love going out fishing every now and then. And who has ever been on a fishing vessel and the waves are choppy and you're just getting beat up and the waves are up, down, up, down, up, down, up, down. And sometimes when you're out deep sea fishing, and those rolls of the waves you're going way high and then the troughs are way low. So very similar to a compressor, right? So when I want my compressor to come on very, very high, and then when it's off, it's way low. And what we try to do, what inverter technology does, it makes those distances from the very top to the troughs at the bottom, they minimize those. So basically what it does, it makes sure that it streamlines it and makes sure that that compressor minimizes the on-off time. And anytime something is off and then back on, it's very hard on the system. The electrical requirements to start a compressor, it's not just like flipping a switch. I mean, it draws and wear and tears on the equipment side. So what that inverter compressor does, it maintains a happy medium so that compressor, when it's operating, it's in a nice, consistent speed.
Just to rephrase that, so since we're not having the extreme highs and lows, running at a lower speed consistently is what's reducing people's energy consumption.
Absolutely. And where we have demand where I need a little more, depending on the zone or what have you, the compressor can ramp up. And really what this all does, it's not to get too technical, but it's driven by a variable frequency drive, or what we call a VFD. And what that VFD does is controls the frequency of the compressor in the outdoor unit. And that's where we get our efficiency, is be able to slow it down, ramp it up based on that load that we see.
Let's get into some of the component longevity, since we're really not putting all that start-stop demand on it that reduces wear and tear on the system, right?
Yeah, absolutely. Things in motion stay in motion. Anytime something stops and you've got to, re-energize it to get it going again, there's wear and tear on it, right? And that's really where we get our efficiency gain. And by using the variable speed outdoor unit, keeping it on, and I'm moving refrigerant to my indoor units, depending how many I have. That could be 1 to 5 in a residential. It could be a lot more in our light commercial and commercial applications. But the thought process is still the same. I'm getting that efficiency because my temperatures are much more consistent. Traditional central systems, and even some of the older thermostats, you would have to have a 2-degree delta before it would energize. So if I had it set at 76 degrees for heating, it would have to be 74 before the thermostat says, hey, I'm at a 2-degree delta, I need to energize. Well, when we're moving that air, moving refrigerant to the space, and we're using variable speed technology, I'm cutting down that, right? So our controllers cut that delta down in half. So I'm in a 1-degree delta. So when I'm sensing it, I know that I need to turn that unit on and I can satisfy. And that's where I get my efficiency.
So we've talked about efficiencies. We've talked about reduced wear and tear on a system. Let's talk about a big one. I think that it doesn't really get overlooked, but it is a big selling feature of these type of systems. Since the fan, the compressors, all that are operating at a lower consistent level, what about sound?
Yeah, sound is big, right? So when these things are at its lowest frequency, humming along at a nice pace, these things are super quiet. I just did a trade show a couple weeks back, and we had some customers coming around, and we had one of our systems going. It was a mock-up system. We wired it to be 115 volt, and just standing there, the outdoor unit was, and we were actually inside. We were inside a training room, had a bucket underneath to catch humidity. No one knew the outdoor unit was running. And I had my laptop sitting on top of this outdoor unit. So super, super efficiency. And another thing too, while we're talking about the quietness of it, keep in mind when we're moving air and constantly moving air at a slower pace, what are we doing? We're removing the humidity out of the space. And again, we talked about it previously. If I'm turning on and I'm shutting off, I'm not running air long enough to draw out the humidity. So another thing that gets our efficiency is by moving that air across the space and having air exchanges across my indoor unit. We're removing more humidity, and that's where we feel the temperature. That's what we feel. We feel that moisture in the air. By removing it, constantly removing that humidity, I can actually increase my temperature, but still be comfortable because the humidity is much lower.
So lower humidity, lower noise, lower energy bills. That's a win-win-win, right?
you know, like I said, if I'm changing out my system, and my wife and I are having that conversation as we speak this week, actually, what are we going to do? And those are those exact same things that you just mentioned. Those are the things we have to talk about, and that's where our dealer network and our contractors come into play to help homeowners and business and building owners and property developers, answer those questions. And that's where our staff come into play as well. So a lot of benefits there.
Biggest takeaway: smoother operation, optimize energy use, wouldn't you say?
Absolutely. You got it.
All right, Matt. Well, thanks for doing this with me today. If there's any topics you'd like us to cover or have any questions, please reach out to us at decodinghvacpodcast@gmail.com.